from the volume.
Okay. So look at your notes. Let's review how we calculate density of some of these objects. So as we talked about yesterday, the formula, density is mass divided by volume. So basically in any problem, any lab situation in which you're going to determine the density, you just need to figure out the mass as we have in the past, figure out the volume as we have in the last section, and then just divide. So if we have a regular shape, okay, we know we can calculate its volume using a formula. So let's what's the formula we would use here for the volume of a cylinder, Brian?
Pi times radius squared. Times height.
Yes,
Yeah.
Brian, excellent. Excellent, Brian. Anyway, this a little hard. Yes. So when we calculate volume, pi times radius squared times height, what's the radius of this cylinder? 1.5 centimeters. The height is 7 centimeters. Pi is 3.14. We do our math.
4.55.
What's that?
I got like
It depends on, how you...
4.55.
Yeah, this is rounded.
Okay.
So the volume of this cylinder is 49.5 cubic centimeters. The mass is already given to you, 519.75 grams. And then we just solve for density. We write our formula, we substitute our numbers in, and then we give our answer with units. In this case, 10.5 grams per cubic centimeter. So let's look at the next example, a rectangular solid. You guys go ahead and solve for the density of this rectangular solid. Show your work there too. I'm just seeing like some random numbers on paper. All right. So what do I have to do here? Stephanie?
Find the volume, find the volume, divide that by mass.
Not quite. But let's start with find the volume. Let's start with find the volume. So how do I find the volume, Stephanie? Yes. In this case, okay, 5 times 6 times 15 centimeters. It's mass divided by volume. instead of opposite last time. The mass is 770 grams. The volume is 450 cubic centimeters, giving me a density of what, Carter?
1.7, which is also known as magnesium.
1.7
Oh.
tablespoons of hummus per pita bread?
Grams, centimeters, cube.
Yes.
Oh, that's great.
So we know density is an identifying property. What element is this, Carter?
Magnesium.
Magnesium.
Wait, what was the answer?
Density is known as an identifying property. Stephanie?
The calculator showed the density was 1.7 water repeated.
Yeah, we were just rounding to the tenths. And so you know what the substance is by looking it up in a chart such as this, which lists the density of various solids, liquids, and gases. Does anyone notice a strange liquid in our chart? Mercury. What's strange about mercury? Dean?
It's liquid metal.
It is a metal that is liquid at room temperature. What else, Grady?
Is it in thermometers?
It's in some thermometers, not as much anymore, because mercury is also a toxic heavy metal that should not be inhaled or ingested, really. But it's still in thermometers sometimes and other things.
Where did they get
Hey, Mom?
It's very dense.
It's extremely dense. Okay, we'll talk about this in a minute, but mercury's density is 13.6, and we know that density is what determines an object's buoyancy. What does that word mean, buoyancy? What are those red and green things in a lake that you have to drive your boat between? Caleb? Buoys. Comes from this word buoyancy. Buoyancy is how an object floats. It's a force that keeps something afloat in a liquid or gas. Does the mass of an object determine whether or not it will float? Yes or no?
Yes.
Yes?
No. Yeah.
No.
It's the density.
Right. No, it's not the mass that determines whether or not something floats. If you have a piece of balsa wood, if you have a giant, enormous chunk of balsa wood that has a mass of 896 kilograms, will it float?
Yeah.
Yeah, definitely. Float very high in the water. It's not the mass that's important, it's the density that's important.
What are boats made out of?
We're going to talk about that Tuesday. So, objects with a lower density, I should rephrase this, float on objects of greater density. Because something I don't like about that phrase. Anyone know what? Your mom?
You said they float on objects, but it floats on liquids and gases?
Yes. So if I have a less dense solid,
What do you want us to say?
it's going to float on top of this piece of gold?
No.
No, it doesn't work with solids. So in liquids and gases, a less dense object will float.
Wait, what?
So what do you want us to
What do
write?
you want?
You can write objects with lower densities float in liquids or gases of greater densities. That would be better.
Sorry it took so long, I had a phone call.
I was waiting the surgery.
Is that,
Just
oh, your
touch.
church?
Thank you. Is man floating on Mercury a video?
No, the
Yeah.
cannonball.
Yeah, that's cool.
Oh, no?
I want to see that video.
It's not.
What? I know, it would be cool if it was a video. Anyway, before I was interrupted, I was saying that not only does density determine whether or not an object floats, it determines how it floats in the water. So if I, a little bit more liquid in this thing, just demonstrate a little bit about buoyancy. We're going to talk more about buoyancy next week. But if I have this container filled with water,
Here's a cube.
Ooh, it's
hold on one second.
Cube sake.
Yeah. So if I place a cube of a material in this water. What does that tell us about it?
Kind of.
It's heavier than water.
No?
Less dense.
More
Denser.
It's more dense. If you say more, you also have to include what?
It's dense.
You can't just say it's more dense. It's more dense
Then
than water. Okay. What about if I have a piece of wood?
Kind of.
What kind of wood is the question?
That's the question.
Does all wood float in water?
It's gonna overflow. Don't do it. Don't do it. It's gonna float. I think it's floating.
Wow.
Actually,
Another
I
metal
had
thing.
one more I wanted to. Okay, so look at these. So look
Stack
look
them
at
on top
that,
of each other.
and then look at this, and tell me if you see a difference. That's hard to tell.
Maybe one of them just.
So,
maybe one of
Not only is density important about how it floats, but how high in the water it floats. So if you have an object that has a density of, let's say, 0.98, is it going to float in water? Yes. How will it float in water? Barely. It will just be at the top of the surface, and only a very small amount will be above the surface of the water. What if you have a substance with a density of 0.5?
Easily.
It's going to be half above the water, half below the water. If you have like a piece of balsa wood with a very low density, most of it is going to be above the water, and a smaller portion is going to be below the water. So it also determines how high and how low it floats in the water. Liquids, if you mix liquids with each other, the more dense liquid will sink to the bottom, and the less dense will float to the top. Okay, you could set up some cool containers with various layers of liquids and gases and objects in it. Yeah. So the point is, depending on density, liquids and gas have different densities, separate out and float or sink on each other. So we just mentioned mercury. Mercury is really interesting because mercury is a metal. It's extremely dense and it's a liquid. And if you look back at this density chart, so obviously, you know, wood is going to float in mercury, but look what else is going to float in mercury. Magnesium, aluminum, tin, zinc, iron, steel, copper, nickel, silver, even lead, a very dense metal. I'll pass around a little chunk of lead. Like, feel how dense this little piece of lead is. That would float in mercury. Okay? So, this guy, this is liquid. This guy is sitting in a tub of liquid mercury. It looks like he's sitting on a solid surface. It's not. He's floating. He's not sitting. He's floating on that mercury. What is the density of a human? Give me a number. Take a guess. It's not on your chart. The overall density of a human.
Well, we know it's gotta be it probably because we kind of float in the water, so we gotta be a little less than water because more than
It doesn't matter the person.
So?
When you have no.
True. So the density of a person
If you breathe out your mouth,
overall is very, very close to 1. In fact, you could change your density above and below 1. How do you bring your density below 1?
breathe in.
You breathe in very
Like if you
deeply,
breathe all your air out, you sink.
expanding your volume, and if you float in pure water, you could float. If you exhale all that water and you slightly decrease your volume, then you sink to the bottom. So our density is right around 1, and again, we could sort of change it depending on whether we breathe in or not.
Superpower.
So this guy is floating in a pool of mercury. Mercury is interesting. The problem is that it's toxic, and so we can't really use it. And this is a little bit, it shows a cannonball floating. something you wouldn't think would float in a
Tub of mercury.
tub of mercury.
Because the Torricelli experiment is portable, and it's portable because the mercury column is short. Why is it short? Because mercury is a very dense liquid, a liquid so dense that cannonballs float in it.
So I have another interesting video I'll show you about mercury. But again, mercury is toxic. I know of a school in which a student's father worked in some industry and had a bunch of mercury in their garage. And mercury is like, maybe I shouldn't say this. It's kind of fun to play with. It like forms like a little ball, and you could like slide it around on a surface. It stays together. And so it's kind of neat. And so this student gave like a bunch of their friends some mercury, and like they were playing with it. And once they found out, the school had to be shut down for like a week, and they had to bring in contractors to go through the whole school, remove all the mercury, because inhaled mercury can be very dangerous and toxic for you. So yeah, that was bad. So we shouldn't play with mercury, but it is an interesting substance.
Can you zoom in on the picture with
to
the
think
guy
about.
sitting at?
Yeah, I would like
Yeah, I wish you could
to see a video of this. There are, and obviously this is not a smart idea to go swimming in a pool of mercury, but it is interesting to see how they float there. And I'll show you